Hello everyone, my name is Darshkumar Jasani and I am going to present 4D radar object detection for the autonomous driving in various weather conditions. So this is the overview of our paper. Basically the autonomous driving means driving of vehicle without human interference. Okay, basically it has a perception model, planning and a control module, and if there is some error in the perception model we cannot go further with planning and control module. The input is our radar cloud image, so this is how the input image looks like. Okay, and this is what the main, like the table of a content. First we'll define the problem, the main objective and the key contributions from the authors. Second, what are the various methods they have used, the experiments, and finally the conclusion, what we have learned from this paper. So what is the main problem? Since the autonomous driving technology heavily relies on the sensors, like the input from the cameras and radar. So this affects, like in adverse weather conditions such as heavy rain or snow, this degrades the performance of sensor, and this eventually leads in the difficulty of autonomous driving. Okay, so we are introducing here four dimensions, which is basically the range, azimuth, elevation, and Doppler. The main objective of the paper is that they have introduced a novel large-scale object detection database and a benchmark for this. They are using 4D tensors. They are using basically four dimensions and 3D object detection neural network to predict the output. Okay, so this is how the data collection looks like. So locations of various sensors on the system or on the car, such as the radar is located on the top, the 4D radars are located at the front of the car, and various stereo cameras on the sides. What is the main challenge? This image shows, like if we are driving for just for the 5 minutes in heavy snow, all the sensors are covered with the snow. Okay, this degrades the performance of our neural network. Okay, so how can we overcome these challenges? Okay, so here we are introducing KAIST-Radar system. Here the radar sensors basically emits the wave. Okay, since they are emitting the wave, they can easily pass through any raindrops or the snowflakes. So if we are driving in heavy snow or fog or rain, it doesn't affect the sensors. Okay, so here you can see this is the 2D like heat map of the front part of the car. So this is our, like the database. There are basically 35,000 such 4D tensor database images in various conditions such as for the overcast or a fog or rain or heavy snow. So these are the key contributions from the authors. They have introduced this KRadar database and the benchmark. They are using this database as an input to a 3D object based neural network. Okay, and for the best, like for the up, it's for the researchers knowledge that this is the first time that anybody has ever used this database, and it's actually performing very well during those periods. So this is how the data distribution looks like for the training and the tests. And it also has the categorical such as light snow, heavy snow, daytime, during night. So these are the various methodologies. They have specified where to install the sensors, how they are collecting the database, how to visualize the data, and what's the our baseline neural network. Okay, so they have done some experiments, and here is the result. Like they have trained two different neural network, one with just the input from a traditional radar system, and second with our new 4D radar which has the height information. They have used the PyTorch and Ubuntu machine to train the dataset, and they evaluate the performance using average prediction. Okay, so this is the result of this experiment. It states like the our new data, like the model which is trained on the 4D radar, is basically outperforming the traditional neural network by 7%. Okay, so this basically means it's performing very well compared to the point pillars or the traditional database. So we can conclude from this that the 4D radar database basically shows us the importance of height information. It improves our the baseline neural network, and this indeed lead us for the key like will accelerate all the development of the autonomous driving. Thank you. If you have any question, just please mail me on this email. Have a great day.